Okay students, now what is almost the last step of heme degradation, that this bile which was formed is stored in the gallbladder. Now we have come to the bile, we have come out of the liver. Okay, so this bile is stored in gallbladder, and where does this bile go from the gallbladder? It goes into small intestine, okay, with the help of bile duct. I hope that you are very clear in these terms. So these are duct which basically connects gallbladder to small intestine. So the bile goes from the gallbladder into the small intestine with the help of this bile duct. Now what happens in small intestine? In small intestine, the conjugated bilirubin is hydrolyzed. It is hydrolyzed as well as it is reduced. Why does it hydrolyze and reduce? Because there are some microbes which are present in small intestine. There are microbes which are present in your small intestine like staphylococcus, like streptococcus. These microbes are present in your small intestine all the time. What does these microbes do? That they convert, they hydrolyze, they reduce the conjugated bilirubin into a substance which is called as the urobilinogen. Urobilinogen. Now, what is the difference between conjugated bilirubin and urobilinogen? This urobilinogen is also water soluble, okay? But the difference is that this conjugated bilirubin, this urobilinogen is colorless, while this conjugated bilirubin is red-orange in color. Okay, so this is the difference. The reduced product of conjugated bilirubin is urobilinogen, which has been converted by the help of microbes present in the small intestine like staphylococcus, streptococcus. Okay. Now, what is the fate of this urobilinogen? It is very important. There are 3 fates of this urobilinogen. What are that possible fates? This urobilinogen can be oxidized into stercobilin. And mostly this is the fate of urobilinogen. Out of 3, mostly this happens, that this urobilinogen is oxidized into stercobilin. Stercobilin is brown in color, and stercobilin is then released into your feces, which give brown color to your feces. Okay. The second possibility is that this urobilinogen, as you know, it is water soluble, so it can travel through the blood, and the blood will go to kidney. So this urobilinogen will go to kidney, and in kidney this urobilinogen is converted into urobilin. Urobilin is yellow in color, and it will be released in urine, and urobilin gives yellow color to your urine. If you're not able to understand it, don't just don't take tension. I'll repeat it a lot of times and you will get it, okay? The third point is that this urobilinogen will go to the portal blood. What is portal blood? You know that your gut does not drain the blood directly into your veins or vena cava. What does your gut do? Your gut drains the deoxygenated blood into a portal vein, and that portal vein firstly goes to liver, and then liver drains the deoxygenated blood into the vena cava. Okay, so gut directly does not drain the blood into vena cava. It drains the blood into the portal vein. The portal vein then drains the blood into the vena cava. So basically urobilinogen enters the portal blood, means portal vein, and portal vein is what? Which is draining the blood from gut to the liver. Okay, so as there is blood in the portal vein, so urobilinogen will also be present in blood. So the urobilinogen will move from gut into the liver. So again it is recycled into the liver, and the liver will again secrete the urobilinogen again into the, it will come into the bile, and then again it will be recycled. It is termed as, this third point is termed as where should I write? Enterohepatic cycle. You know what is meant by entero? The duodenal cell is termed as the entero. Okay, you know, in embryology you must have studied enteron, that basically responsible for the development of gut. So entero means duodenal cell, hepatic means liver, and cycle means that it is recycled. Okay, so this urobilinogen is again goes back to the liver, then it is again secreted into the bile. It is again it is recycled. Okay, so what was the last step? That the bile was stored into the gallbladder. It enters into the small intestine with the help of bile duct. In small intestine, the conjugated bilirubin present in the bile is converted into urobilinogen. Do remember, heme was red, biliverdin was green, bilirubin was red orange, and this urobilinogen is colorless. Now there are three fates of urobilinogen. It can be oxidized into stercobilin. The stercobilin appears in feces and give brown color to the feces. As it is water soluble, so it can go to the kidney. The kidney can convert the urobilinogen into urobilin, which is yellow in color and gives yellow color to your urine. And it can go to the portal blood. So the portal vein drains from gut into the liver, and it can go back to the bile. And in this way, it is recycled, which is termed as the enterohepatic cycle. Okay. Last interesting thing I want to tell you about heme degradation is related to the bruises. You see that whenever the bruises are formed, their color changes time to time. Firstly, they are red, then they become purplish, then they become yellowish. So what is the reason behind that? So basically, the bruises are formed when there is a blood leakage into your skin. Okay, so there is blood leakage into the skin. So whenever there is blood leakage, so the blood is oxygenated. In the start, the blood is oxygenated, it carries the oxygen. And you know, whenever the oxygen is present into the blood, it can reflect a maximum of the wavelength. Try to understand this point. Whenever the oxygen is bound to hemoglobin, it can reflect a maximum wavelength. And you know what is the maximum wavelength? The maximum wavelength is red. That's why when you draw the arteries and veins, you draw arteries red. Okay, because you can see arteries on your skin, okay, but they appear red, or you draw them the red. Okay, so oxygen bound to hemoglobin, maximum wavelength will be reflected and it will appear as red. So firstly, whenever there is blood leakage, the oxygen is present in your blood, so the first bruise due to the inflammation, which is produced as red in color. Now what happens next? After 1 to 2 days, the blood start getting deoxygenated. It starts removing its oxygen. And do remember, when the oxygen is not bound to hemoglobin, when there is no oxygen in hemoglobin, then the capacity of hemoglobin to reflect the maximum of wavelength decreases so much that now it can reflect only the minimum of wavelength. And you know what is the minimum wavelength? The minimum wavelength is blue in color. That is the reason that your superficial veins, the veins under your skin, that appears blue. It doesn't mean that the blue blood flows in your veins. No, it means that the blood is reflecting, the vein is reflecting the blue wavelength. That is why the vein is appearing blue. Otherwise, if you take the sample of blood from your vein, it will never be blue. It will always be red. It is just the reflection of light which will make it blue. Similarly, as the bruise is also on the skin, so it will reflect some kind of light. So as the blood is deficient in oxygen, so it will reflect the minimum of wavelength, which is blue. So firstly, the bruise was red, then this bruise will be converted into blue color after 1 to 2 days, blue or some kind of purplish color. Now what happens next? Firstly, the blood had oxygen, now the oxygen had been removed. Now what happens? Heme degradation will be start. You know, as the oxygen is removed, then it will start degrading the heme. What happens? That firstly, biliverdin is produced. What was the color of biliverdin? It was green in color. So the bruise will start turning some kind of greenish color. Now what will form the next? Billirubin will be formed. Now what will be the color of bruise? It will turn into a red or some kind of orange color. Red, orange or yellow color. Okay. So the heme degradation intermediates are responsible for giving colors to the bruise, and with the help of colors we can just diagnose how much severity of the bruise is, because if it is red, it means it is the initiation, but if it has turned into yellow or reddish orange, then it means it is severe. Okay, so this was the last point about the heme degradation. Now I'll just summarize the lecture for you, and I hope that you will get it very clearly. Okay, my dear aimers, now here is the summary to the lecture. We had 120 days completed by RBC. It contained hemoglobin. It was degraded into globin and heme. Now revise with me. The globin was converted into amino acids by peptidases, and these amino acids were recycled. Now this heme was converted into bilirubin. Which two things were removed? First, iron plus 2 and carbon monoxide. Carbon monoxide acted as a signaling molecule and as an anti-inflammatory substance. And what three things were added into the heme? There was heme oxygenase, oxygen, and the NADPH, from which we just use the electrons. Now this biliverdin, it was green in color. This biliverdin was reduced with the help of NADPH reductase and was converted into bilirubin. This bilirubin is unconjugated bilirubin and it is red-orange in color. It was insoluble in water, it was fat soluble, so it can't travel the blood, so it was bound to albumin. It formed bilirubin albumin complex. The bilirubin albumin complex was transported then into the liver. So this all process till here, it occurred in macrophage. It can be macrophage of liver or it can be macrophage of spleen. Okay. Now this bilirubin albumin complex, it was formed in plasma. And the next step, the formation of bilirubin diglucuronide, it occurred in hepatocyte of liver. Okay, and this was in bile. This process occurred in bile or gut, or you may say that gut. Okay, because next is the small intestine, so it occurred in gut. So it was converted into bilirubin. It was unconjugated. The bilirubin was transported into liver by bilirubin, transported through plasma by bilirubin albumin complex. It was a larger molecule, so we needed a carrier protein ligand to transport the bilirubin. It was the facilitated diffusion. Do remember, it was facilitated diffusion, and the bilirubin entered into the liver. The UDP diglucuronic acid transferred the two molecules of glucuronic acid, converted into a conjugated bilirubin and formed bilirubin diglucuronide. So this bilirubin diglucuronide is basically a conjugated bilirubin, and the bilirubin formed over here was unconjugated bilirubin. Now this bilirubin is transported into bile with the help of MRP2 protein, and it was active transport. Do remember these points. It was active transport. Now this bile is transported into bile, small intestine with the help of bile duct. Now in small intestine, microbes were present. What happened, that conjugated bilirubin undergoes hydrolysis and reduction with the help of microbes and is converted into urobilinogen. Do remember, it is green, it is red-orange, and this urobilinogen is colorless. But this urobilinogen has three fates and then it appears colored. When it is oxidized into stercobilin, which is mostly, and this stercobilin is then brown in color. That's why feces appear brown. As it is water soluble, it can travel to kidney. So it goes to kidney, converted into urobilin, and it is yellow in color. Urobilin appears in urine and gives a yellow color to the urine. And what happens, that the third fate is that this urobilinogen enters into the enterohepatic cycle and is recycled back. The two most important things were also how carbon monoxide acts as an anti-inflammatory substance, and I also told you how the color of bruises changes with the time and why. So this was all about heme degradation. I hope it is very clear to you. If you have any queries, you may ask in the comment section, and if you have got the lecture, then do like the video, subscribe to my YouTube channel. See you in the next video. Allah Hafiz.